Hey guys, I just wanted to make a quick video here, just showing a couple more experiments I've been doing today. So these lights here, these 120 volt lights, they seem to work the best compared to these 12 watt lights. And I was wondering why. When I hook these ones up to the diode chains, the voltage gets like stuck down at like 7 volts. So they don't light up all the way. Even when I add the ground, maybe it goes up to like 8 volts. They don't light up all the way, and but they still get decently bright. But these ones here, these 120 watt or volt ones, which are also like double the power, 3.6 watts, and these ones are like a watt or a watt and a half. But these ones get frickin' bright, like almost full brightness, and I was wondering why. You'd think these ones would get brighter. So I'm thinking it has something to do with whatever circuit's LED driver that they use in here to convert it down. And some of these lights, this isn't one of them, but some of the lights can work on 120 all the way up to 240, and same with some like power bricks like this, and that's the main part of the experiment today. But these guys here, when you hook them up to the diode chain, the voltage gets locked right at 120 volts, like exactly what they need to run. So I gotta be something to do with the circuit that's in there. So I was thinking, I have this power brick here. I was looking at it today, and I don't know if you can see that. This camera doesn't focus the best on close-up stuff. But anyways, it's a 100 volt to 240 volts, so it automatically will take 100 volts from America or the 240 in other places, and it puts out 1 amp at 5 volts, so 5 watts. But I don't know if it's putting out the full voltage, but it'll be easy to test now. I just got to cut one of these wires open, find the power one, and put my amp meter in line while it's charging, and see if it's indeed doing the full 5 watts, because that would be cool. But anyway, so I was thinking something with these circuits. It's got to be the capacitors, and maybe there's a little tiny isolation transformer in there. I'm not sure. I'm upset the LEDs that I took apart, I just tossed away the circuit boards, but maybe those are the cool part of it anyways. But so I figured I'd try it with this. I hooked up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the 1N4148 diodes, all in series. And I actually, on this chain, I haven't tried the other chain, but this is just the one I had on the table. So this one, I got 2 diodes on each one in parallel. And I don't know if that changes anything. Well, I'll try the other one. But anyways, I just wanted to make the video quick because I think this is really neat what happens here. So I just got the the light here for my camera. And right on the top there, there's, here, I'll turn it back on. You can, oh, I don't know. But here, I'll just turn on the Tesla coil here, and I'll show you what happens. So I got the Slayer Exciter SEC by Dr. Stiffler, whatever you want to call it, I suppose. And the top plate attached here. And the plate seems to add more radiant effects to it. But anyways, I'll hook that up there. And, oh, sorry. This one keeps popping off here. I just gotta put you down for a second. Alright. Turn on the coil here. It is 2.9 watts it's running at right now. Alright. We'll take this. Very simple. Just the diodes hooked up, positive, negative on there. Doesn't matter which way, because there's going to be a bridge rectifier in there that just straightens it out the way it wants anyways. And then I'll put this near the Tesla coil, and look at that. See those little lights? Sorry, I got a video. Look, it's freaking charging. And if that is putting out 5 watts and charging that up at 5 watts, then you can look at that right there. Let's see. 3 watts. Charging up still. And it doesn't care how many of these diodes I put around, as long as they're not in the exact same spot so they mess with each other. Oh, I could charge 10 of those off of 3 watts. I don't think I need to say any more, I guess. That is neat. So I wonder what's in here. I think Joel did some... Joel Leglace did a video about the capacitive power supplies, and you can tell when they are those because they're light, very light, no transformer, maybe even just a very small one in there. But capacitors, so I'm gonna look at those schematics, see how it's working. But these are dirt cheap, so why not just parallel these? If I can get 5 volts constant out there, then there you go. A little off-grid solution, maybe, I don't know. Neat, 3.8, 4 watts. Oh, jumped up to 5, down to 3 again. And it's charging. And here, I'll just let you watch that. It'll bounce around too, just with nothing happening. And it's probably mostly just me. Oh, there we go. Yeah. Touching wires and stuff like that. Ow, frick, burned myself. Ouch. Yeah, but anyways, that was pretty neat. I'll I'll find a USB-C wire I don't care about and cut it open, and I'll do an actual measurement there and see if that's putting out the 5 watts. And if it is, then what do you know, right? Everybody go buy yourself some stuff. Get some diodes, get some alligator clips, a breadboard, some MOSFETs, a pack of resistors, a pack of diode, or a pack of capacitors, just one of the variable ones, because you're gonna have to play with it depending on what your coils are. But I'll tell you what this is. This is 75 feet, and this one here is 6 feet. And if you watch mtech's videos, there's way better ways of doing this. I just threw this together because I'm lazy and I'm poor, so that's what I could do. I got the wire out of an old microwave transformer, and yeah, so this, and just old ABS pipe around. So this cost me a couple dollars to put together, and it can be improved. If you go watch those guys' videos, you'll learn a lot more than I can teach you, because I'm still learning. But this is cool stuff, and I think everybody should do it. Take a learn. It is high voltage, so I mean, maybe not everybody, but if you build it right, it just burns you a little. You're not going to the hospital. But yeah, anyways, thank you very much. Have a good day, guys.